Today we're going to talk about proving triangles similar. Last week we talked about proving triangles congruent. Today, same type of things we're going to look at, sides and angles, except there's a different process. Since we're not saying our triangles are congruent, we're saying our triangles are similar. What similar means is that they are the same shape, but you're going to see that they are different sizes. Okay, so we won't be able to say that they're congruent, but we will be able to prove them similar. So last week we learned there are 5 ways to prove triangles congruent. You'll see today there are only 3. So the first way to prove triangles congruent is angle, angle, and the symbol for similarity is this little squiggly. It does look like the negate symbol, but with similar triangles, that is the symbol for similar. So angle, angle, and then we're going to look at all of these. Side, side, side similarity, and side, angle, side similarity. So those are the only 3 ways. So 2 out of the 3 look very similar to congruent triangles, but the process is different, and that's what we're going to look like. And then the angle, angle, we did not have any of that kind last week. So let's take a look at this. All right, the first way is angle, angle similarity. Okay. And if you read here in the box, it says if 2 corresponding angles are congruent, then the triangles are similar. So the key here is you have 2 pairs of corresponding angles and they are congruent, which is a little weird because we're talking about similar triangles. But if you remember the video we watched last week, they showed us why they wouldn't be congruent triangles because your sides could be different lengths. But what you want to look for is 2 pairs of corresponding, and I'm going to abbreviate, congruent angles. So let's look at an example. So here's an example. So I look, clearly they are not congruent, okay, because one is bigger than the other. So we definitely can't say they're congruent triangles. They're not congruent. Triangle JAM is bigger than triangle OUT. So now we're going to look at similarity. So if I look, angle A is congruent to angle U. So that is just like last week, 1 pair of angles. And then angle M is marked as congruent to angle T. So that's another pair of angles. And that's all you have to do for angle, angle. You just have to show 2 pairs of corresponding congruent angles. And so what we could say here is triangle JAM, and remember, you do have to match up your parts correctly, is similar to, so we're going to use our similar symbol, triangle. Now, what matches up with angle J in the smaller triangle? Angle O. Good. What matches up with angle A? Angle U. And what matches up with angle M? Angle T. Remember, that's not the only way you could have written that. Okay. If someone else wanted to say triangle AMJ, then you would have to say it's similar to triangle UTO. And again, you can do any variation of those letters as long as you follow the shape of your triangle. So angle, angle, you just have to have 2 pairs of corresponding congruent angles. So let's look at some examples. Number 1, are these 2 triangles similar? Now, starting out, I say, hey, angle P is congruent to angle B. They're both 100 degrees. But then I look and say, well, angle N does not match. It's not congruent to angle E. And then I have no numbers on angle I or angle T. Before we decide we don't have enough information, what you do want to do is figure out your missing angles. So we want to know this angle and this angle. So how do we do that? Well, we remember that the 3 angles of a triangle add up to 180. So for this triangle, we're going to add angle P and angle N. So that's 100 plus 30. That gives me 130. And then we're going to subtract that from 180 to see what that leaves us. So that leaves us 50 degrees. Okay, so that angle's 50. Now we're going to do the same thing for this triangle because we don't want to make a decision until we know all of the information. So we're going to add angle B and angle E. So 100 plus 45 gives me 145. Subtract that from 180. Okay, and so that gives me, let's see, 35 degrees. And then I'm going to put it on my picture. Now I'm going to double check. Do I have any other corresponding congruent angles? The answer would be no, right? Angle P is congruent to angle B, so that's one pair of angles. But then I don't have any other corresponding congruent angles. So in actuality, this would be no, they're not similar. Okay, we only have one pair of angles. That's not enough information, and so we're done. All right, so let's check this one. Which triangles are similar to triangle A? And notice it gives me triangle B, triangle C, both or none. So I look at my picture and go, okay, I got 57 here and 57 here. So that's one pair of angles. Then I notice I also got 44 and 44. So one pair of angles, two pair of angles congruent. So triangle A is definitely similar to triangle C. Now we don't want to count out triangle B because I do see the 44, right? Wouldn't that be congruent to the 44 in A? But I want to find this angle. Now, why wouldn't I find the angle in C that's missing? Because I don't really need to, okay? Not right this second. But I do want to find this angle to see if it's 57 and is congruent. Now, could you have found this angle in triangle C and this angle in triangle A? Absolutely. What you would have found with triangle A and C, that missing angle, it would match. Okay. But let's see what we got. So we're going to add 79 and 44. Okay, that gives me 123. Then we're going to subtract that from 180 and see what I have left. So that would give me 57. So I'm going to put that on my picture. Now, once I do that, what I should notice is, look, 57, 57, they actually are congruent. Okay, so angle A is also also similar to triangle B, because again, you have angle, angle. Okay, you only need two pairs. Now, could we have done the math? We could have added 57 and 44, okay, subtracted from 180. Okay, we would have found that 79 and that 79. And then you wouldn't have to match all of them. You only need to match two pairs of corresponding congruent angles. All right, what about 3? Okay, you guys pause 3 and try it. Now, first glance, do you have any congruent angles between A and B or C? I do see that we have 54 degrees here and 54 degrees here. Okay. And that's it, right? There are no other pairs of corresponding congruent angles. But before I make a final determination, I do want to go ahead and fill in the other angles that are missing to see if I can't get a second match. So for angle A, I'm going to do 58 plus 54. And again, you can type this into Desmos. You don't have to do this by hand. So that gives me 112. Subtract from 180. So that gives me 68. So I'm going to write that on my picture. Now, I do notice, where do I see another 68-degree angle? Right, down here. So I'm going to say this angle is congruent to this angle. Now I have two corresponding angles that are congruent from triangle A to triangle B. So A, I know, is similar to B. Okay, you can't eyeball these. You need to have the numbers to back you up. So again, I'm going to go ahead all the way through and find my missing angles. So here, 54 plus 68 gives me 122. 180 minus 122 gives me 58. Okay. Then I'm going to come to angle C, do the same thing. 51 plus 47 gives me 98. 180 minus 98 gives me, what, 82. So again, put that on my picture. Now, looking at this, I do see that I have another pair of congruent angles between A and B. And you should. If you have two, notice you've got the 54 congruent to the 54, the 68 congruent to the 68. Okay. By default, the other pair of angles should be exactly the same. And they are. But then I could look at triangle C. Anything in triangle C congruent to any angles in triangle A? No, right? So we can't say that A is similar to triangle C. So it actually ends up just being triangle B that works here. All right, so you take a minute, see if you guys can do 4 and 5, pause the video, and then come back and check. All right, so hopefully you pause the video. So let's see what we got. At first glance, I do see that angle B is congruent to angle E. Okay, they're both 81. But then I see I have no other angles that are congruent. So what am I going to do? I'm going to find the third angle for this triangle and the third angle for this triangle and see, is there anything that I can match up? So I'm going to say 81 plus 60, 141. Then I'm going to say 180 minus 141, see what I have left. So that would leave me with 39. I'm going to write it on my picture. It's 39 degrees. Then I'm going to come over here and I'm going to do 81 plus 40, which gives me 111, 180 minus 111, see what I got left. That would leave me 69, and so I'd come over here and put that on my picture. Do we have any other angles that are congruent? Okay, good. No, right? Close, but not quite. A little bit off on both. So, are my triangles similar? Good. That would be a no. You only have one pair of congruent angles. We don't have enough information. We did the math. There are no other congruent angle pairs, so they're not similar. You just got a big triangle and a smaller triangle. All right, what about number 5? You had to remember something about this before you started. Okay, starting out, I do see angle C is congruent to angle F. Awesome. So I got one pair of congruent angles. I need 2. I look, I don't have anything else, but before I decide, I'm going to find this angle right here and this angle right here to see if I have any. So I'm going to say 90 plus 35, that's 125. Then I'm going to subtract 125 from 180, and that gives me 55. I'm going to put that up here in angle A. Now, once I do this, you actually don't really have to come over and find this angle, because you should see, hey, look, this angle's 55, and so is this angle. There's my second pair of congruent angles, and so, yes, my triangles are similar. Okay. Now, if you wanted to be thorough, you would say, let me just make sure. You'd add 90 and 55 over here. You'd come up with 145, subtract from 180, Okay, and you'd find out that angle E is 35. So you could have done the 55s or you could have done the 35s. But yes, your triangles are similar. Make sure, because sometimes they will ask you to write a similarity statement. So that's where you would tell us what triangles are similar. You can put the letters in any order, just follow the shape of your triangle. So I did ACB, similar to triangle, match up your parts. So A matches up with D, C matches up with F, and B matches up with E. Okay. Again, how you write that is up to you, but just make sure that your pieces, your angles match up or correspond. All right, so that's angle, angle. That's the first way. Now, let's look at side, side, side. This is different from last week. Last week, we just had to find sides that were congruent, corresponding sides that were congruent. For similar, we're not going to be looking for congruent sides because you're not going to have any. They're similar, not congruent. Similar means one is bigger than the other. So obviously your sides are not going to be congruent if one triangle is bigger than the other. So how do we do this? Well, we got to read what's in this little box. If all corresponding sides are proportional, then the triangles are similar. Okay, if all sides are proportional. So in this little bullet point, make yourself a note. Your sides are not going to be congruent. They have to be, we're going to say must be proportional. And I'm going to show you how to check that. Now, you're going to want Desmos. Desmos will make this a lot quicker and a lot less painful. So what you're going to do for things to be proportional, you're going to match up your corresponding sides, and then you're going to reduce them, or if we're with Desmos, you can reduce them and or change them to a decimal. For anything to be proportional, they need to simplify or reduce to the exact same fraction, or if you're just changing the fractions to decimals, to the exact same decimal. So let's see what that looks like. Okay, this is how you check to see if your sides are proportional. Again, they're not going to be congruent. Okay, they could be, but they're not because you got one big, one small. So when you go to match these up, what you want to do to set up your check, and we have to see this on your paper. You can't just say side, 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 and you don't have any fractions written. You just start with the smallest side in either triangle. So what's my smallest side in triangle LFO? My smallest side is 15. So you're going to do 15 over what's your smallest side in your big triangle? 30. Good. And again, we're not saying they're congruent. Obviously, they're not. We're just setting up a fraction. If sides are proportional, they will reduce to the same fraction, or if you're just going to divide to the same decimal. So then you start with your small. Always stay consistent with how you set these up. So then I'm going to go to my medium side. So what's my medium side in this triangle? It's 20. You're just going to leave a little space. What's my medium side in the bigger triangle? 40. So that's my second fraction. And then go to your longest side. And again, go back to the triangle that you started with. So that would be the smaller triangle, 25. What's your longest side in the bigger triangle? 50. Now, if you're really good with fractions, you can probably reduce these in your head, okay, which is great. But if you're not a fraction person, totally fine. Then we're going to pull up Desmos. Let me find my Desmos. There he is. Okay, and what you're going to do is you're going to type in each fraction. So the first one was 15 over 30. Now, 0.5, Desmos always defaults to decimals. Or if you like fractions, you can hit the circle. It'll turn it to a fraction. But we're going to leave it as decimals just because that's the way Desmos gives it to us. Then we had 20 over 40. Looking good so far. Now, all three of them have to divide out to give me the same decimal. So they all divide out to give me 0.5. So what that tells me is that, yes, my sides are proportional, and what we want to see on your work are the 3 fractions that you wrote, and then we also want to see the decimal that you got. So we got 0.5, we got 0.5, or again, if you like fractions, you can write the fraction. They are all equal. They're all exactly the same. I always put a check. That's my verify. And so, yes, okay, they are similar, and you would say by side, side, side similarity. But to say side, side, side similarity, we have to see what you set up and how you verified that the sides are proportional. Now, the question we always get is, some people say, well, I didn't start with the little triangle, I started with the big triangle. You can absolutely do that, okay? You could have done 30 over 15, 40 over 20, 50 over 25. Now, when you divide it out, you would have ended up with a different number. It actually would have come out to be 2. 30 over 15 would have been 2, 40 over 20 would have been 2, 50 over 25 is 2. They all match. That's what you're looking for. That when you divide them out, that they all divide out to the same thing. That tells you that your sides are proportional. So these do require, you can't just eyeball these. Okay. Now, looking at question 6, let's look at this. Just eyeballing it, what you should notice right off the bat is the only information they are giving you are side measures. 112, 56, 84, 40, 20, 30. So the only option that you have in this picture is going to be side, side, side. Okay, we don't have any angles. Okay, they didn't give us any. So angle, angle, not going to work. Again, side, angle, side. If I look, I do have some sides. I need 2 pairs according to side, angle, side, but I have no angle measures that I can say are congruent. So just by default, this picture that they're giving us is probably going to be side, side, side. But you cannot circle that until you set up your fractions. Again, doesn't matter which triangle you start with. I tend to just start with whatever picture pops up first. So I'm going to start with triangle PQR, which is the bigger one here on the left. Again, when you set these up, don't stress yourself out trying to flip this triangle up to see what matches with what. Just go small, medium, large, and it will always work. So if I look at triangle PQR, my smallest or shortest side is QP. So that is 56. And what's my shortest side or smallest side in the smaller triangle? Yeah, 20. So they go together. Then I go to my medium side, and again, go back to the triangle that you started with. We started with the bigger triangle. Go back there to get your second number. You have to write your fractions consistently. You can't decide, oh, I'm going to come over here and grab 30 or 40 to put on top. Nope. You started with this 56, then you got to come back here. So what's my medium side? PR, which is 84. What's my medium side in the small triangle? 30. Okay. Go back to the triangle you originated with. So then we're going back over here. My longest side is KQ, which is 112. What's my longest side in the smaller triangle? 40. Okay. Now, again, not my thing. So let's see if I can split screen it without making a big disaster. Probably not. Nope. All right, so I'm just going to click on it. So we're going to check our fractions. So the first one was 56 divided by 20, or 56 over 20, gives me 2.8. Okay. So again, they all have to be the same. So then I have 84 over 30. Come back over here, 84 over 30, 2.8. Okay, looking good. Then we have to do the last one, 112 over 40. Again, you can't assume this. You have to show us this, because all 3 have to come out to be the same thing. And I'm happy to report they all come out to be 2.8. Okay, so these are all 2.8s. They all simplify to the same decimal. Okay, yay, makes me happy. So yes, your triangles are similar. Now again, you cannot just circle that. You need to show us the verification. All right, let's look at number 7. Okay, now looking at the picture, just looking at it, I notice, hey, look, they're giving me a pair of congruent angles. So now they're starting to mix it up a little. So I'm like, okay, if they're giving me a pair of angles, I know, and I look at my picture, I realize they gave me no side measures, none. So it's not going to be side, side, side. I have to have numbers to write my fractions to check my proportion. I don't. So side, side, side's gone. So is side, angle, side for the same reason. Okay. I do have the A. I have a pair of angles, but I don't have anything else. Now, the only thing it might be is angle, angle, or not similar. So just like last week, remember we had to mark certain things last week when we were talking about congruent triangles. Okay. They were vertical angles and shared sides. And then if they threw some parallel lines at us, we could have done something with those. But if I look at this picture, is there anything I can mark myself? The vertical angles, absolutely. So I can mark these congruent. Why? Because vertical angles are always congruent no matter what kind of problem you're doing. So once I do that, I look and I say, okay, I have one pair of congruent angles that they gave me. I just marked my others. Okay, so I got angle, angle. Yes, they're similar. We like angle, angle because there's no fraction writing. You don't even need numbers. Okay, you don't have to. You just have to make sure that they have congruent corresponding pairs, and you need 2. Okay, so those were similar. Not by side, 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 though. And notice I didn't set up any proportions when we did angle, angle. You do not set up proportions for angle, angle. You only look to see if they are congruent. All right, let's look at this one. Okay, same thing. Are the triangles similar? If so, tell me how. Looking at the picture, which ones do I know it can't be? Definitely not angle, angle, right? Nothing's marked as congruent. They're not giving me any numbers on my angles, so not angle, angle. Which then says not side, angle, side. Because again, you need at least one pair of congruent angles, which we do not have. So the only thing that might work is side, side, side. But we won't know until we check. Side, side, side is your proportion. So is side, angle, side when we get there. So again, does not matter which triangle you start with. Depending on which one you start with, your fractions may look a little different than your neighbors. Okay? But you should all come to the final conclusion if whether or not they're side, side similar or not. So I always start with the first one. So I'm going to start with the bigger one. Again, start with your shortest side. So my shortest side in triangle FGE, 72. What's my shortest side in the smaller triangle? That would be 8. Then I go medium. So medium side in the big triangle, 117, this right here. What's my medium side in the smaller triangle? 13. Good. And then large. My largest side is 126 in the big triangle. What does that match up with in the little triangle or correspond with? 14. Okay. You have to make sure your small was small, medium, medium, large, large. Okay, if you start mixing it up, it'll give you the wrong answer as far as whether or not they're proportional. Same thing, notice that my top numbers, 72, 117, 126, all come from the same triangle. You have to stay consistent with that. Okay, you can't have this number right here come from your big triangle and then come over here and this number right here come from your little triangle. You have to set up your proportions consistently. All right, so again, fraction it, Desmos it or not. 72 divided by 8 I know is 9. I don't need to type that into Desmos. So let me change colors. So now 117 over 13, I don't feel like doing that in my head. So come over here, take these out, 117, 13. Oh, comes out to be 9, good. Okay, so that one works. And 126 and 14. So let's see if that gives me 126, 14. Also gives me 9. Okay, so this does work. Yay. I always equal them out, check them off. My sides are proportional, so yes, they're similar by side, side, side. All right, you try number 9. Pause the video, come back, check and see what you got. So hopefully you pause the video. And looking at the picture that they're presenting to me, I notice all they're giving me are sides. Okay, so I can cross out angle, angle. Okay. No numbers, no angles marked as congruent, not gonna be that. Same thing, I can cross out side, angle, side. They're not giving me any angles, there aren't any vertical angles or any parallel lines that I can use to help me get some angles, and no numbers, so it's not side, angle, side. Looking at this one, angle, side, angle, is that even one of our ways? Nope. So hopefully, just by looking at the picture, you can tell it's either going to be side, 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 or nothing. But since they don't give me a none or none of the above, it's probably side, side, side. But let's verify that and make sure. So again, start with whatever triangle you want. Just to show you, I'll start with the smaller ones. So the shortest side, I go, oh, there's 2. Then just pick one. Okay. 4. What does that match or correspond with in the bigger? What's the shortest side? 8 or 8. You could go with either. Doesn't matter. Then you go to the middle side, but then you're like, there's not really a medium side. I still got a 4. And that still corresponds with the 8. And then what's my longest side? 9. And that corresponds with your longest side and the other, which is 18. Okay, do the math. Now, the good news is I can do this in my head if you can't go to Desmos, but you will get 0.5, 0.5, and 0.5. They all match. So yes, side, side, side similarity. But again, on your work, we're going to ask to see this. You can't just circle an answer. All right, so for the sides, you have to check their proportions. Last one, side, angle, side. So this one kind of takes a little bit of both. You need to have 2 corresponding sides that are proportional, and you also need to have the included angle that's congruent. So with this, you are going to have to check your sides, make sure they're proportional. You are not going to have to do anything with the angle, and this is the part that people mess up on side, angle, side, because then they tell us, oh, it doesn't work because they throw the angle in there. The angle only has to be congruent. The angles only have to be congruent. Okay, so you do not write them as a fraction. Let me say that again. You do not write angles as a fraction. You just have to look at them. Are they congruent? Yes or no. So looking at this picture, if you look and pay attention to the information, these are actually easier than last week because they will pretty much show you the setup. So if you look, you got a 17, which is a side, and then you have an angle that's 47, and then you have another side that's 37. So just looking at the picture, it looks like it's going to be side, angle, side. Okay. That's the pieces of information they're giving me. But you have to check the sides, not the angles, because I look at the angles and go, this is 47, this is 47. They are congruent. That's all you need to verify. Angle A is congruent to angle M. That's all you have to verify, either by the markings or the numbers. So check. Yes, there's your pair of angles. You're not going to put the 47 in a fraction because you're not checking to see if they're proportional. You're checking to see if they are congruent, which obviously they are. So we do have to check the sides. So I did this 17, it's shorter than 37. Since they're only giving me 2, I can't do small, medium, large. But 17 is the shortest. So what does that correspond with in the bigger triangle? In the bigger triangle, it corresponds with the smaller number, so the 51. Then go back to my little triangle because that's where I started. I'm going to look at the 37. Okay, so the 37 corresponds with the 111. So now I have to see, do they give me the same decimal or reduced to the same fraction? Technically, I'm trying to figure out, are these two fractions equal? Okay. And rather than, sit and try to figure all that out, we just type it into Desmos. So again, don't care. 17 divided by 51. Okay, 0.3 repeating. That's a lot of 3s. We're not going to write all those 3s out. We're just going to say, okay, 17 divided by 51, see if I can fit down here, is 0.3 repeating. Now, we want to know if 37 divided by 11 is the same. So again, I'm going to type it into Desmos, divided by 111. And hooray, it is. Now, when we say they have to be the same, they have to be exactly the same. If we had done that divide and we got 0.36, then it would have been a no. They have to be the exact same decimal. So yes, it works. So yes, your triangles are similar by side angle side. And you do want to put your similarity symbol, because if you leave that off, then you're saying they're congruent. Okay, if you leave your similarity symbol off, then you're actually saying your triangles are congruent. And looking at them, you know they're not, right? One is clearly smaller than the other, so they would never be congruent. Okay, and we will mark it wrong. IXL will mark it wrong. Kahoot, quizzes, SOL. If you forget that similarity symbol, if it's a do-it-yourself, type it in, hand type in the answer or whatever, they'll mark it wrong. So make sure you have that symbol. Now, notice, did I put the 47s into a fraction? No. Again, let me say it one more time because people mess this up and then they try to say, oh, they're not similar because it's because they put the angle in. The angles you just check for congruence. That's it. So all you do for the angles is make sure that you have corresponding angles congruent. You do not write a fraction. Okay, you don't reduce the 47 over 40. You don't do that. Just verify the congruence. All right, so a couple more examples before we turn you loose. So let's look at this. Now, this is kind of a weird picture, but if the triangles are similar, state how. So I look at my picture, okay, and it's a little weird because they made the angle so dark, but what I see is I see in both triangles a side and then an angle. This angle right here looks a little weird because they made it so dark. And then another side. And in both pictures, I see side, then an angle, then a side. So just by looking at it, I probably would think it's side, angle, side. It's not angle, angle. Okay. Don't have another pair of congruent angles. Don't have a way of getting another pair of congruent angles. There's no verticals I can mark, nothing like that. I also know it's not side angles, side, side, side. The reason I know it's not going to be side, 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 just by looking at the picture, is I have no number on the third side. The only way I could do side, side, side is if I had 3 numbers that I could put into fractions and check. So I know it's not that. So again, by looking at your picture, you should be able to figure out that it's probably side, angle, side, but you want to check the sides before you say yes. So we're going to set up our fraction. They only gave us 2 numbers, so you start with the smallest. Smallest is 12. Again, you could start in the bigger triangle and start with 36. It's just a personal preference. Doesn't matter. When you put it in Desmos, you'll get a different number, but you're still looking for the matching. So 12 corresponds with, what's the shorter? 36. Okay. And then we check 15. Okay. That matches up with 45. Now we're trying to see if they reduce down or give us the same decimal. And so what we do is we type them into Desmos. Okay. And again, I just use the decimals. Okay, 12 over, no, I totally forgot what it was. 36. If you like fractions, you're more than welcome to look at the fraction because that reduces to 1/3. Okay, you could write 1/3. Or, again, I just always go, it's 0.3 repeating again. So 15 and 45. Do they match exactly? Remember, it has to be exact. And if you don't like all the decimals, if that's like, oh, I'm going to miss it, then fractions, you can see it better with the fractions. Okay. Yep, they match exactly. Okay. Whether you look at the fraction or the decimal equivalent, okay, they both come out to be 0.3 repeating. Again, we need to see that on your paper. We don't want to just see circled answers with anything with a side in it. We want to see what you got when you checked your proportions. So yes, side, angle, side. All right, so let's look at this one. State the postulate that proves these triangles are similar. Okay, so they're giving us the 3 choices and then not similar. I look up at my picture. I see one side, 2 sides, one side, 2 sides. Okay, so I know it's probably going to be side, 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 or side, angle, side. The problem with that is I don't see any angles marked. So before you start circling not similar, because you don't think you have enough information, is there anything you can mark? You always want to look for that. Yeah, there is, right? Verticals. Okay, aren't vertical angles congruent? So we have an angle. There's your A. So we know it's not angle, angle. Okay, we already said that. We know it's not side, side, side because they only gave us 2 sides, not 3. So probably side, angle, side. And if you look, that's what it looks like, right? If you watch or kind of zoom in on what they're actually showing you, you got a side, and then you got the angle, and then you got the side. And you have the same in the bigger triangle. You have the side, and then you run into the angle, and then you have the side. So yeah, it's definitely probably going to be side, angle, side. But before we say yes, what do we have to do? Yep, we got to check our sides. So it doesn't matter which triangle you start with. Again, what's my smaller side in the smaller triangle? 8. So I'm going to put 8. What does that correspond with? Again, don't try to flip it and do this and that with in your mind with the picture. Just go, what's shorter, 28 or 49? 28. So it corresponds with the 8. Go back to my little triangle because that's the triangle I started with. So now I'm going to look at the 14. What does that correspond with in the bigger triangle? 49. Okay. And again, not a fan of fractions, so you're going to pull Desmos. This time you only got to check 2. 8 over 28. Okay, really weird decimal. 14 over, what do we say? 49. Oh, no, come back down there. Okay, do your decimals match exactly? Take a look, double check, yes. Again, if you don't want to have to kind of eyeball all those numbers, because that's a long decimal, change it to a fraction. Okay, fractions sometimes are easier to look at, determine if they're exactly the same. So they reduced to 2/7, and I'm actually going to use that instead of trying to write out the 2.28 blah, 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 blah. So they both simplify to 2 over 7. So they are equal. Yay. So yeah, side, angle, side does work, but you have to check your sides. All right, number 12. How do these triangles appear to be similar? Giving me the 3 options and then not similar. So I'm looking at it and I'm like, okay, the markings they have, none of them match. So none of those angles they're showing me are congruent. So do I have anything I can mark before I claim not similar? Yep, I can do vertical. So since they have 1 mark, 2 mark, 3 marks, you have to make it look different. So I'm going to do 4, which is slightly obnoxious, right? So there's one pair of congruent angles. Do we have any other way to mark any other pair congruent? No, right? Without numbers, we wouldn't. So this actually would be not similar. Because again, excuse me, if you look, angle E only has 1 mark, angle K has 2, and angle J has 3. None of them match. Okay, so I can't get another congruent pair of corresponding angles. So that's it. Not enough information on number 12. All right, so this one always blows people's minds because they can't see the big triangle because the little triangle is part of the big triangle. So what I always tell people is redraw them, like separate. You got this itty bitty triangle right here, BGR, okay, but it's part of or on top of the bigger triangle, which is ZGP. So what do I say to people before you try to do anything is draw them separate. Okay, so if I draw my little triangle, this is G, this is B, and this is R. And they have a mark in R, so I'm going to put that back. All right, now draw your bigger triangle, just separate. And they don't have to be works of art, just draw it bigger. So the bigger one is ZGP, and they do have angle P marked, and they actually have it marked congruent to angle R. So I do have 1 pair of congruent angles. Okay, now just looking at this, do you have any side? Nope, so it's not going to be side angle side because we need to write a proportion. Without numbers, we can't. Same reason for side, side, side. So the only thing we could do here is angle, angle. Okay, process of elimination, a good test-taking skill. Here's what you have to notice about this. The original way they showed you the picture, excuse me, is the little triangle sitting on top of or part of the bigger triangle, right? But I said, hey, redraw them so you can see what's really happening. What you have to see is, there's something that you have to see. Does anybody see it? Yeah, angle G is in both triangles, right? Isn't this corner right here a corner of your little triangle, but it's also the corner of your bigger triangle? And so wouldn't, if angle G was 50, wouldn't it be 50 in the little triangle and the big triangle? Yeah, right? Because it's technically congruent to itself. So once I realize that, or I see that with the little triangle and the big triangle, and that's why this says look for non-labeled parts, they're not going to mark it in the original picture. They're not going to put these 2 marks on it because they're going to assume that you know, hey, if they have the same corner here, that it's equal to itself. Okay, so they're trying to trick you. So angle G is congruent to angle G. It's congruent to itself. There's my second pair of angles. So yes, angle, angle. Okay. But again, you have to show that. Mark angle G congruent to itself. All right, last example. So again, when you're doing, similar, you can narrow it down pretty quickly based on the picture they're giving you. I see no angle measures. There's no verticals. They're not, on top of each other. They don't have a corner that's in both. So there's no angle measures. It's not angle, angle. It's not side, angle, side. The only thing it possibly could be is side, 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 or they may not work, not similar. So again, I have to set up my fractions. Can't do it by eyeballing it. Not even I can eyeball this and go, yeah, I know what it is. So start with the shortest. I'm going to start with the big triangle. So my shortest side of my big triangle is CB, which is 48. That corresponds with the shortest side in the smaller triangle, which is 8. Then I go to my medium side in my big triangle. So my medium side would be 72. That corresponds with, what's my medium side in the smaller triangle? 12. Good. And last but not least, go to the biggest side. Biggest side is 84. That corresponds with the biggest side over here, 14. And then I divide them out. Now, some of you can divide out. You're like, 48 divided by 8. I know that's 6. Well, then you don't have to type it into Desmos. 72 divided by 12. Some of you guys might know that is 6. Okay, 84 divided by 14. Okay, actually does come out to be the same. Okay, so the side does work. Now, when would side not work? Let me just show you. Okay, if you just come over to this box, because it's going to happen and then somebody's not going to realize that it doesn't work. So you might have something like 7 over 14, okay, 10 over 20, and then 22 over 52. I don't know. I'm just making up numbers. So you come along, you're chugging along, and you're like, oh, 7 over 14 is 0.5 or 1/2. 10 over 20, 0.5. So far, so good. And some people get excited and go, okay, I'm done. Always, you've got to check the last one because look, okay, and I made this up so it wouldn't work so you guys could see it. If I do 22 divided by 52, does everybody see how I get 0.4, blah, 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 blah? Okay, so is 0.4 the same thing as 0.5? No, right? This does not match the other two. If that ever happens, they are not similar. Okay, when we say all three have to match, they have to match exactly. If you get a question like, and because they're going to do this, you're going to see it happen. They might give you, it might come down to 1/3, which is 0.3 repeating. Okay, and then they might have something like that. Okay, where they're close, okay, but they're not exact. Okay, if that happens, they're not an exact match. That would be a no. Okay, and again, if you're like, well, I'm going to forget that because I see the 0.3 and think we're good, well, then change them to the fractions so that you can see they are not equal fractions, not in a long shot. Okay, if it's too hard for you to tell, if you don't like, if you're afraid that you're going to say these are equal because you see 0.3, okay, when we say they have to match exactly, we mean exactly. Okay, 0.33 repeating is not the same fraction, decimal is 0.34375. But again, if you think you're going to mess that up, okay, look at the fractions. Ask Desmos to change it back to a fraction. Okay, you'll always know if the fractions match because they will look identical. Sometimes people get confused when they're super close with the decimals. Just remember they have to match exactly to be considered proportional. All right, so thank you for watching. If you have any questions, let us know, and we're going to turn you loose on the practice.